So the production possibilities frontier is the line or curve that shows all possible combinations of two outputs that can be produced using all available resources. This is commonly put on a XY plane with one quadrant, as we can see right here. And there are three assumptions in this problem without labor specialization. The first assumption is that this country can only produce two goods. And so whenever you're making a graph, you assume that all else in the economy is equal, and that this graph only pertains to two goods. And these two goods are wheat or shorts. And there's only one factor of production right now, which is labor. Other inputs are land, capital, and capital can be machines, buildings, factories, anything like that, etc. And there's no labor specialization within the country, which basically means that all workers have the same skills and abilities. So it says, on the space provided below, draw the production possibilities frontier. Put the millions of bushels of wheat on the vertical axis and the millions of shirts on the horizontal axis. Label the following points on the PPF. So we're going to start off with A. The vertical axis is wheat in the millions, and the horizontal is shirts in the millions. So point A says all of the workers of the country produce wheat. 50 million bushels of wheat and 0 shirts are produced. So we come over here and we put 50 on the vertical axis. And then all workers of the country produce 0 bushels of wheat and 100 million shirts are produced. So we're going to go over here and put 100. And then from there, we draw the line between the two. So that, as of now, is our PPF, our production possibilities frontier. So now we move on to point C, which is half of the workers produce wheat and half of the workers produce shirts. So in order to find those 2 points, we would take the number of bushels of wheat if every worker produced wheat, and we would divide that by 2. Because half of the workers are producing wheat. So that would be 25. So we would come right here. That'd be 25. And then half of the workers produce shirts. So we would cut that number down to 50. So that would be half. And then our new point on the production possibilities frontier for this specific scenario and situation would be right there. It'd be 25 and 50. And it's important to note that this point is attainable and efficient because it is along the line of the possibilities frontier. An unattainable level of production would be somewhere inside this curve. That would be attainable, but it would be inefficient because we want one of our points to be along this line because it uses up our available resources and gets us the max amount of production possible. A point outside this line would be unattainable because we don't have the right amount of resources or technology to achieve that. But if we would, that would obviously be ideal, but we can't. And how we get there is through something later in the chapter called international trade. So point C is right here, and that is attainable and efficient because it uses all of our resources, and it's along the PPF line. So point D, an unattainable level of production that cannot be achieved given the current level of technology and available resources, would be somewhere out here because it is not on this line, and it is outside of the graph. An inefficient point, which is possible, would be somewhere around here. It is inside the production possibilities frontier, which means, yes, it is possible, but we would still have leftover resources used, which means we are not maximizing our production and therefore maximizing our profit in the economy. So now we move on down to shifting the PPF. There are lots of different ways that the production possibilities frontier can be shifted. And there are 4 scenarios. 4 scenarios on here. A, B, C, and D. So A, thanks to technological advances in wheat, growing 1 worker can produce more bushels of wheat than before. So we have, moving over to A, over here, we have wheat, and we have shirts. And our original line was 50 and 100, right? This was our original line. So when we have workers who now can only produce more wheat than shirts, we'll see that we'll rise on the wheat side, and our shirts will stay the same, meaning that our slope has changed and it has gotten steeper. So that is how the PPF would change for that scenario. And then we move on to B. Thanks to technological advances in shirts production, 1 worker can produce more shirts than before. So we have our original PPF. This way. And we can produce more shirts. That means we would grow and our slope would change and it would get flatter. And our slope would get flatter because the shirts are along the horizontal axis and we are increasing production in that area. So wheat would not be harmed at all, but our shirt production would increase, therefore changing the equilibrium point, which we'll find out about later. But our slope would get flatter because our production of shirts is increasing. So now we move on to C. And C is the population of the country has increased. So if the population of the country has increased, that means our labor force has increased. That means the more workers we have increased. So we have our basic function, our basic line on the PPF, which is our base year scenario. And then if more workers increase, and they're not specialized in anything, they all have the same abilities, that means production in all categories will increase for the whole economy. So wheat production will increase, and so will shirt production increase. So our slope is not going to change. We have a parallel shift in the PPF, which means that no change is in our slope. But a parallel shift is something that is usually very beneficial for all economies, and that's going to change the supply and demand curve a lot. But the PPF curve will be a parallel shift. It would increase in all categories. Moving on to scenario D. Label our graph real quick. D is the productivity of labor has increased in both wheat and shirts. This is going to give us 3 different types of scenarios. There is what we just looked at, which is a parallel shift in production. So if we have a parallel shift, which means that there is an equal change in the production of wheat and shirts. So if production of both wheat and shirts both increased in the exact same way, in the exact same number, we're going to have this parallel shift again. But if there's an unequal change in productivity, and we'll say that there is a higher increase in shirt production. So if there's a higher increase in shirt production, then we're going to have that flat slope. This will still increase, but this will increase more. So the shirts will still have a higher increase, which means we would get that same flatter slope that we see in situation B. Now, if we have a different scenario where production in wheat increases more than production in shirts does, we would have a smaller scenario where we would get a situation like we had in situation A over here, where our slope would get steeper. The main thing about these, though, is that there are three changes. There are three changes. The first one is same increase for both, which means parallel. And then there's an unequal, which is more shirts. And when we have more shirts, that means a flatter slope. And then an unequal with more wheat means a steeper slope. So that is basically how the production possibilities frontier works in a base year standpoint. In a base year standpoint up here. And then in a multi-scenario on how it shifts. Thank you.